Okay, so first of all, let's look at a couple atomic energy basics. And you've already been learning a lot about the elements and their composition. Um, but let's keep going with this. So when you look up an element on the periodic table, there's a couple different numbers that you're going to be looking at. And one of them is the atomic number, and the other is the mass number. And this is all covered in your textbook. The atomic number tells you the number of protons in the atom. And consequently, it also indicates how many electrons are in the atom because it has to be balanced. So let's draw an atom. 3, 4, 5, 6. Okay, so here's 6 protons in our atom. So here's our electron cloud. And so, somewhere in this electron cloud, we're going to have 1, 2, 3, 4, 5, 6 electrons to balance it. But this would not be a stable atom. It would not hold together. And there are a lot of different reasons for this. But basically, we have another subatomic particle, neutron, which is not charged, and it comes in and makes a kind of nuclear glue that helps hold those protons together. And the interesting thing is, well, first of all, let's talk about this atom. And it has 6 protons, and it has 6 neutrons. So if you look on your periodic table, you will see that the atom with 6 protons is carbon. So that is the atomic number of carbon. So C6. Now, it also has 6 neutrons. And the way you indicate this is the mass number. So first of all, let's label this. This is the atomic number. And this here is the mass number. And I don't just write 6 up there, but I add all of the protons and neutrons, giving them each a mass of 1. And so we end up with 12 for the mass number. So looking at those two numbers, you can figure out how many protons and how many neutrons the atom has. Now, here's the important thing here. So we know what atom we're dealing with. We're dealing with carbon. It's got its mass number, but it turns out that you can have a number of different versions of carbon. You can have an extra neutron, so that would become now 13 C6, like that. So it's carbon, 6 protons, but now 7 neutrons. You can also have carbon 14, like that. And that's how you say that, by the way. This is carbon 13. This is carbon 14. Now there's these different versions of the atom are called isotopes. And all of the isotopes are radioactive, except for the one that is found most abundantly in nature. And this we'll clarify this as we go along, but here the idea is that the version of carbon that's found most predominantly in nature is carbon 12. And the reason is it doesn't break down over time. But the other versions of carbon will stick together for quite a while, but then at a certain point they will spontaneously decompose. And this is a process called radioactive decay, and we'll talk about this in detail. But all of the isotopes decay except for the one that is found in nature most abundantly. Now here's the thing. Nature will make carbon-14, and it does this at a consistent rate. And so some of the elements, some of the carbon in your body and around you is carbon-14. But over time, that carbon-14 will decay down. It'll get to carbon-12 and make a radioactive decay product. And it'll basically decay towards stability. But these other versions of carbon, these isotopes, will stick around for a while. Now, we'll talk more about this in detail and this whole process of nuclear decay. But before we do that, and before we get into talking about how long the isotopes live for, we need to talk about the products of radioactive decay and the whole process itself. And then we can get into talking about how long carbon-14 lasts, or how long the different types of thorium last, or the different types of uranium. But let's talk about the three main types of radioactive decay. So we'll go to a new slide. And still recording. Okay. Yes. All right. So let's talk about radioactive See, I can't spell close up. Let's try again. Radioactive decay. Now, again, we're only talking about the nuclei of atoms. We're not concerned with the electrons in these reactions. So, basically, you have a nucleus. It's composed of protons and neutrons. And it can, now this is bizarre but true, it will spontaneously, meaning there's nothing that causes this to happen, at least discernibly. It happens randomly, but if a nuclei is unstable, after a certain amount of time, it will spontaneously decay. And there are three different particles, or four different particles, that can be emitted. One of them is the alpha particle. And the alpha particle is simply a helium nuclei. So this atom can spontaneously emit a helium nuclei. So it's got two protons, and it emits a helium-4. Sorry, hold on a second. It's the wrong one. Hold on. Okay. There we go. So it emitted a particle that has two protons and two neutrons. And it emits it with some considerable energy. And so this particle is moving at a high speed. Now, here's the trick. If that particle hits soft tissue, say an internal organ, it can penetrate a cell and damage the DNA within the cell and cause damage that way. And so you have to be careful near things that are emitting these helium particles. And so you need to wear gloves and some kind of protective clothing, but really not too much, because the particles are so massive and their energies are generally pretty low that they don't have enough to really penetrate and cause a lot of damage. This type of radiation is called alpha. And these particles are called alpha particles. Okay, let's go to the next video and we'll talk about the other types of radiation.